I hope you received that homework message and you have started working on it. See, there have been multiple questions about what kind of book to make or this or that. Let me make one thing very clear again. I suggest that you make proper notes, okay? As we are going to study more and more chapters, you are going to get some important sentences, concepts to remember, the formulas to remember, diagrams to remember, and all that. Okay, so what I suggest is that you just make one notebook. I repeat, you just make one notebook to solve whatever physics you are doing. Clear? Right? Okay, but obviously what will happen is that in that case you will not be able to find your notes or anything. Right? So this is how I suggest or I recommend everyone does it. Whenever we start a new chapter, like yesterday we started chapter 2. Chapter 1, forget about it, I'd say. Completely ignore chapter 1, no problem. Okay? Let's talk about chapter 2. So we just started chapter 2. Now when we start a new chapter, I suggest that you leave some 10 pages of your notebook blank at the start of the chapter. Let's say you put it right in chapter 2 and then you leave 10 pages blank. Alright, and start writing after that. So what to do with these 10 blank pages? You can write down the important sentences or concepts or formulas or diagrams over there in short. So this way one notebook will have all the physics sums that you have done, all the derivations, this, that. It will also have the notes in the same. Right? It will also have the notes in the same. So let's say whenever you want to refer or revise chapter 2, you can just read the first 10 pages. Okay? They will give you the important formulas and concepts and everything. Understood? If you are going to make, see, remember in 11th and 12th we don't worry too much about what books you make or anything. More important is what you learn, because checking what you have done, that's a secondary thing. Right? Understanding the concepts, whether you understood everything, whether you can write it properly in exam, whether you can solve questions in exam, that's the main thing. Right? So that's why remember, whatever things we are doing, whether you are making notes, whether you are making notebooks, homework notebook, classwork notebook, all that, I am okay with it. I don't have any problem whether you do it this way or that way. But the main thing that I suggest is that try to write it in such a way that you will be able to later find it. Okay, because you'll have to read it or revise it. And not just one time. Let me tell you, you are going to have to revise it probably 10 times in these 2 years. Alright? So, my suggested method, I have already told you that you just make one notebook. No homework, no classwork, no nothing. Just one notebook where everything goes. Alright? Okay? At least for the time being, that's a suggested method. Right? Okay, when schools become offline or something, then we might have to change the method a little bit. Excuse me. But for the time being, I think this is fine. Okay, now some of you said that you have doubts. I am not going to solve your doubts right now. Okay, you have been given time till tomorrow to submit your homework. Right? So, tomorrow you are going to get the answer key of all those questions. That is, you will be given the answers. So then you can compare which one you are not getting right, and then we can do a little bit of discussion about that. Alright? Okay? Again, remember, the focus is not on what you write. Like it has been made clear so many times that whatever exams you give, all of them have MCQs. And it's not like 10th standard where you'll get line questions that okay, this is one line from the book and let's put a blank over there and ask this. No, this is not 10th science. Okay, this is not 9th standard science. Alright, here concepts are the main thing, whether you understand what's given over here in the book and you can use it. Okay, so standard notation, I know I didn't mention specifically what standard notation, I know that, right? I'll just take one moment to explain what is standard notation, not more. Standard notation is nothing extraordinary, it's just what you have been writing all the while. Suppose you have got some number like 7.27 into 10 raised to 4. This is scientific notation. Okay or not okay? This is scientific notation. How to write it in standard notation? Very simple. 7.27 into 10,000. Okay, multiply this. So what do you get? 72700. Did you understand? Did you understand or not? This is called standard notation. Got it, everybody? This is called standard notation, right? Very easy, isn't it? Writing without the power of 10, writing like you have been writing normal numbers, that's called standard notation. Right? For example, 0.0045, this is standard notation. Understood? 0.0045 is like standard notation. Okay? Well then. I hope that doubt is clear, if anyone has it. Now, so let's continue with the chapter. Remember, we are doing all these kind of maths only because it's the basic, right? Without all these maths, you're not going to be able to do physics, very frankly speaking, right? Now, so let's talk about units and quantities today, right? We have started the chapter 2. I told you that quantities are anything that are associated or linked with a number. So basically quantities are things that can be measured. Quantities are things that can be measured. Again, do not worry too much about definitions, right? Understanding what is quantity is more important than memorizing that a quantity is something that can be measured. That sentence is not so important. What is important is you understood this. Quantity, that something which can be measured, right? No, the idea, they are not same in value, they are same in value but they are not scientific notation. Only one of them is scientific notation. Can you repeat this? This is what? What is meaning of repeat this? The video is blurred? Yes. Okay? It's clear now? Because Akshay, I was not writing, how can you believe? Yeah, fine. So I said that quantities are something that can be measured, right? So color is not a quantity, mass is a quantity, length is a quantity, distance is a quantity, alright? Okay, such things are quantities, right? Human population on earth is a quantity. Remember, human population on earth is also a quantity, right? So things that you can measure, those are quantities. Now, whenever we have a quantity, it's very, very likely that there is some unit also. Because without unit, there are lots of confusions, right? So basically, unit is something which is a standard or universally accepted reference. Okay, a unit is something which is a standard or universally accepted reference for comparison of quantity. What does this mean? Okay. So, this means when we suggest a unit, for example, kilogram, let's say, right? For example, kilogram. Now, we have actually decided exactly what to call a kilogram, and it is universally accepted. Universally accepted means whether you are here in India, or let's say you go to USA, or you go to Africa, or you go to Japan, wherever you go, everywhere the meaning of 1 kg is taken to be the same, right? Okay, everywhere the meaning of 1 kg is taken to be the same, and everyone knows what 1 kg is, right? That's why we say it is universally accepted. Now, why do we use it to compare, right? To explain that, let me use a weird unit, okay, which is not a very nice one, right? Okay, suppose I would decide that the distance between my elbow and the tip of my finger, let's say distance between my elbow and the tip of my finger, right? I am going to call it 1 Ishan. Okay, suppose we define a new unit of length. What's the unit of length? Distance between my elbow, okay, and the tip of my finger. We call it 1 Ishan, suppose. You see, this, although this looks like a very smartly designed unit, everyone, can you hear my voice? Can you hear my voice? Yeah, I know. That's why I'm asking. Video is paused. Yes, correct. Okay, just give me 1 minute. Okay, I'm trying to correct this. Alright? Now hopefully things will work. Okay, there's not much we can do about it at this moment, right? So I was saying that suppose we would define the distance between my elbow and the tip of my finger as 1 Ishan, okay, named after me, of course. So this is, well, looks like very good unit in my viewpoint because I can easily measure anything. Suppose we'll draw a line. Okay, let's say I've drawn a line segment, and then I ask you what's the length of this line. Then I'll start putting my elbow from here to there. Okay, 1, and then maybe 1.5, isn't it? So I can say that length of this line is 1.5 Ishan, isn't it? I hope you get what I'm saying. But the problem is, although this looks like a very convenient unit, I'm sure you would have you'd have seen people measuring things like this. Okay, have you seen or done this ever in your life? Okay, but that's not a universally accepted reference. Why? Don't you think that every person will have a different distance when they do this? Yes or no? Every person will have a different distance when they do this. Correct or not? Also, if you think of the distance between elbow, and the finger, then also for every person that would be different. So then we have 2 choices. Whenever in any corner of the world they want to measure some length, let's say they want to measure some length, they are going to call me, hey Ishan, come here, we want to measure length. Do you think this is convenient? Do you think this is convenient? Okay, so this is a very bad idea. I hope you realize that. Okay, so what do? We don't base the units on such things which are variables. Okay, we don't base the units on such things which are variables, right? That's why these units that we use, for example, kg. Okay, so what is 1 kg? What is 1 meter? What is 1 second? All that, right? All these units are fixed exactly. right? Everywhere in the world they are supposed to mean the same thing, right? That's it. Okay? And also for references in every country, listen to this carefully. For references in every country, there are ways to determine the exact unit or the exact reference. Basically, for example, I'll tell you about kg. Kg is something which is said to be the mass of a particular cylinder. Mass of a particular cylinder, okay, which is originally kept in France. Again, all this is just basic information. Nobody is going to ask you this in exams, right? So 1 kg is actually the mass of a particular cylinder which is kept in France. So that's the reference. That is the reference which we use for comparison. Understood? So anything which will have double mass, then that cylinder. Anything that will have double mass then that cylinder will have how much mass? 2 kg. Did you understand? Anything that has double mass then that cylinder will have mass 2 kg. Clear or not? Everyone, I am waiting for your interactions. Yes or no? Is this clear? Double mass means 2 kg. But then you will always have a problem. Every time you want to measure mass, you have to go all the way to France. Very costly, don't you think? So what have they done earlier? They have made replicas. You understand what is the meaning of replica? Replica means copy. Replica means an exact copy. And what they have done is that by making replicas, they have given it to all countries. Okay, at least all the major ones. So now what we can do is, here in India also we have got this 1 kg cylinder. Here in India also we have got this 1 kg cylinder. So that is going to behave as the reference for here. So whenever someone wants to compare any mass, they can compare it with 1 kg, right? So this is how you can compare things. Alright? Okay. But yes, of course, I am not talking about measuring. See, I didn't say this is how you measure mass. I only said that this is how you could compare the mass. Alright, I only said that this is how you could compare the mass if required. Measuring is a different thing. Alright, so that's about units. Now, let's talk about 2 types of units. Basically, units can be split into 2 types. 1, base units or fundamental units. Fundamental means basic, right? Okay, base units or fundamental units, and on the other hand, derived units. On the other hand, derived units. Alright, base units or fundamental units and derived units. Let me give you an example. Normally people take unit of length meter and unit of time second. Okay, length, its unit is meter, and time, its unit is second. So these are base units. Normally people take these 2 as base units. Then one example of derived unit is unit of speed. Okay, roughly speaking, speed is length upon time or distance upon time, right? Length or distance means similar. Do you understand what I have written? Speed will have unit meter per second, yes or no? Speed will have unit meter per second, yes or no? Alright? Everyone, keep interacting. Whether you understood, yes, no, something. Alright? Now, meter per second. Look at this unit. Do you realize that this unit itself is made up of 2 other units? Do you realize that this unit itself is made up of 2 other units? Yes or no? What does that mean? If it's made up of 2 other units, it is a derived unit. Meaning clear? Derived unit is something that is made using, is something that is made up of other units. Meaning is clear or not clear? Okay. Okay. Let's not only two, remember, there are not just two fundamental units, there are so many fundamental units actually. So let's talk about that now. Okay, I am going to erase everything on the board. I hope you have noted whatever you wanted to. This was just an example of derived unit. Alright? Now, so generally people are using some particular systems of units, right? Particular systems of units, right? Let's write name of few. There are more which are used in some other parts of the world. We don't have to worry about that again. Okay? Finally, I'll tell you which is the system that we will always try to use. Okay, number one, first of all, is CGS. Okay, CGS system. Now, what is CGS for? C is for centimeter, G is for gram, and S is for second. Okay, S only, S for second. Centimeter, gram, second. Okay. Centimeter, gram and second. So why do we write it like this? When we write it like this, what we mean here is that these are base units. I repeat, when we write CGS, what we mean is these three are base units. Clear? Okay. Number two. Another system of units is FPS. It is called British system. Okay, it is called the British system. F stands for foot, P stands for pound. Pound not as currency. Okay, pound as in unit of mass. The center one here is unit of mass. This is unit of length, and this is unit of time. Right, so foot, pound, second. Did you understand? Foot, pound and second. FPS. Clear? So here, so basically the British people, they still use this. Right? They still use FPS system. Right? Okay. Number 3. MKS. Okay, MKS. So M stands for meter, K for kilogram, and S for second. M stands for meter, K for kilogram. Okay. Now someone has a question here. Does foot mean our foot length? Come on. No, foot means 1 foot. The way I hope you realize that you measure your height in foot. Okay, that foot, not the length of your foot. Okay, please don't joke like that. S means seconds. Time unit. S, second. Remember, everyone remember this. Writing SEC for second is wrong. Let me make it very clear. Writing SEC for second is wrong. Symbol of second is X, never SEC. Okay, just like that, writing kilogram in any other way except this is wrong. For example, kg wrong, kg wrong, kg wrong again, kg wrong again. Only this is right. All these are wrong symbols. You have to make sure that you use the correct symbols. Okay. Even this is wrong, mind well. You might say, sir, I am writing the first letter capital. No, this is not English. Okay, this is physics. Here the rules are different. Now, okay, so there are some rules like that. Don't worry, I'll not tell you all the rules right now. There's no need. Okay? Alright? Over the time, you'll gradually know what are the rules. Right? Don't worry. It will come to you naturally. It's not at all difficult. Alright. So this is MKS. Meter, kilogram, second. And last one, the one that we use. All these, they are outdated. These are outdated. They were used earlier. They are not used anymore in the world. This last one is called SI. SI actually is a French word. It's a short form of a French word. System International or something like that. Okay? Basically, its translation is International System. Its translation is International System of Units. SI. Okay? Not IS. Again, all this is more just kind of basic information. You should not expect anyone to ask you what is full form of SI. No, that's not what you learned in 11th and 12th science. Alright? Okay? So SI system is what we use. Now, what are the fundamental or basic units of SI that I am not writing here because there are 7. So let's make a new table. Alright, this topic is complete here. Let's make a table where we are going to write down all the fundamental units and the quantities. I am erasing everything. 4 systems of units. Done. So SI system or SI, yeah, you can just put title SI, no problem. So here we are going to write down numbers 1, 2, okay. First of all, quantity. Unit means SI unit, okay. We call it the SI unit. Alright, quantity, unit, SI unit name actually, this is name, SI unit's name. And then we are going to write SI unit symbol. Okay, then we are going to write what is the symbol of that unit. That is, whenever you are doing calculations and you are writing symbols, then what should you write? Don't worry, all this is very easy. Let's begin. Number 1, first one is length. Quantity's name is length. Remember, length, distance or length. Alright, quantity's name is length. The SI unit for length is meter. Okay, SI unit for length is meter. M-E-T-R-E. Or you can also write M-E-T-R. Different parts of the world people use different spelling. It's okay. Symbol is common. Small m, not capital. Okay, not capital. Small m only. So meter symbol is small. Number 2, mass. Okay, mass is a quantity. Okay, its SI unit name is kilogram, not gram. Everyone be careful. This is how you write kilogram. This is how you write kilogram. No capital or anything. Again, no capital. Alright? In unit names, nothing is written in capital. Alright? In unit names, nothing is written in capital. Next, symbol kg. Kg. Alright? K is for kilo and G is for gram. But like I said, don't put it this way. That would be wrong. They have to be this way. Got it? This is right, this is wrong. Clear so far? Clear so far or not? Now there are 7, like I said. These are 2 done. Number 3, time. Second. See, this is not symbol. This is name. What is the name of the unit? Second is the name of the unit. What is the symbol of that unit? S only, not SEC. Not SEC. Number 4. Now remember, order is not important. Okay, it's not like you have to memorize that first is this, second is this. No, order is not important. You can put them in any order, everything is still okay. Alright? So number 4 is thermodynamic temperature. Basically, the key word for you to understand right now is temperature. Focus on this. Thermodynamic temperature, but temperature basically. Now, so far, I'm sure you would have seen a few units of temperature. Can you tell me 1 or 2 units of temperature that you know? Can you tell me 1 or 2 units of temperature that you know? The ones that you know are not from the book. Remember, when I tell you anything, you should follow it properly and do it honestly. Right? I didn't say you read it from the book or anything. Remember. So make sure you do it the way I tell you. Okay? Just units that you know. That's it. Okay? Yeah, most people I'm sure know degree Celsius. Okay, it's called degree Celsius. And I think people also know degree Fahrenheit. Okay, and some people know about Kelvin also. Very good. Alright, some people know about Kelvin also. So the SI unit is Kelvin. The SI unit is Kelvin. I know Kelvin is the name of a person, but still K will not be capital. Kelvin is the name of a person, but still K will not be capital. But here it will be capital. Alright? Here it won't be capital, but here it will be capital. Alright? Is this clear? When it's name of a scientist, everyone, or when it's name of some person. Okay? Scientists are persons. So when it's name of a person, the symbol will have first letter capital. I repeat. When it's name of a person or scientist, the symbol will have first letter capital. Got it? That's why although here it's small k, but here it is capital K. Understood? Clear or not clear? Let me give you one more example. You know what is unit of force? Everyone, do you know what is unit of force? Do you know what is unit of force? Very good. Newton. Very good. Newton. So, you know, the name of the unit in SI is Newton. Like this. We write the unit like this. Okay? Small n. But then when it becomes symbol, it becomes this. Just like here. I hope you see what I am saying. Clear? Clear or not clear? Symbol will have first letter capital if it's name of a person. Alright? Now, next. So, like I said, the rules are not tough really. Okay? Suppose today you couldn't remember it, don't worry at all. Because we are going to be using these units very frequently, you will get used to it. Alright? It's fine. Don't take stress. Next. Electric current. Electric current. This is something which you have studied in 10th. Do you remember unit of current that you have studied in 10th, everyone? Do you remember unit of current? Very good. Ampere. Small a, M-P-E-R-E. Ampere. Again, ampere is a name of some person. So that's why capital A. Did you understand why capital A? First letter capital. Alright? Ampere. Next, number 6. Amount of substance. Amount of substance. Okay, amount of substance is basically how many molecules it's got. Okay, it's a relation with that thing. Okay, amount of substance is basically something that is related to how many molecules or atoms or particles it's having. Okay, so the name of that unit is MOLE, mole. Have you heard of this? Have you heard of mole? Have you heard of mole? Very good. And the symbol of mole is small m o l, because mole is not name of a person. Alright. Symbol is MOL. I know you might be thinking, what nonsense. There's just one letter short and you are calling it a symbol, but that's how it is. Alright. Okay, MOLE and MOL. Now, last one. Basically, we use these sticks. Let me tell you that fact. We use these sticks in these 2 years very frequently. Right? But the last one, it is something which you would never need in these 2 years at least. You know, if you study physics later, you definitely need it. Okay, so up to these 6, we are going to use them very frequently. And now the last one, number 7, which we never use in these 2 years. It is the quantity called luminous. It is called luminous intensity. It's a quantity called luminous intensity, and its unit is candela, not Cinderella. Okay, not Cinderella. The unit is candela. That's not my problem. There you go. Okay. It's there, but we don't use it in basic physics at least, right? Later on, when we study a lot about radiation and all that, we have to use the unit candela because it's referring to luminous intensity, that is related to brightness of a light source. Okay, this is related to brightness of a light source. Anyways, the symbol of candela is small c, small d, not capital. Why not capital? Because candela is not name of a person. Understood? Candela is not name of a person. So that is CD. Okay. Saleh, I get to your question. See, these are 7 fundamental quantities. Like I said, if you remember the last topic, I told you that in other systems we have MKS, NCGS and all that. Those are fundamental units. But what are fundamental units in SI? Here are the 7 fundamental units in SI. So you can change the title a little bit. Okay, SI and its fundamental units. Change the title a little bit. So it will be clear what we have written here. SI and its fundamental units. Understood? Okay, so these are the 7 fundamentals. Where are the derived quantities? There are hundreds of derived quantities. We are not going to write all that. Okay, there are hundreds of derived ones. Newton, Joule, Pascal, kg meter per second. Okay, these are some examples. There are many more, right? Coulomb for charge. Alright? Okay, these are some examples of derived units. The 7 fundamental units and all other are derived. Okay, 7 fundamental and all other are derived. You don't have to worry about derived units and remembering them. Okay, if you try to remember hundreds of units, you'll go crazy. With time on your own, you will learn all this. Okay, right? So these are the 7 fundamental units. Now, one last thing to wind this topic up, and today's class is when? Okay. It is that you have to study the same thing in chemistry as well. Alright, you have to study the same thing in chemistry as well. Right? So this has been done here. It will not be repeated in chemistry. I hope it's clear to everyone because it's the same thing. Why to repeat it again? Okay, same information, same ideas over here. Alright, so all these is there in chemistry syllabus as well, but won't be repeated. I have taken care of it. Okay, right. Now what are you expected to do? Remember this. What are you expected to do today? You should be able to remember all the 7 quantities with their units and the symbols. I will give you a shortcut or a mnemonic. Okay, I will give you a mnemonic to remember. You can remember these 7 letters. Tell ATM. Okay, you can remember these 7 letters. Tell ATM. They correspond to each of these. Let's see. Suppose T for temperature, done. E for electric current, done. L for length, another L for luminous intensity. Okay, A for amount of substance, T for time, and M for mass. Did you understand? Did you understand this? Okay, so you can just remember those things. That way it will be very easy to recollect. Fine. Alright, so you should be able to remember all of this here. Okay, at least the first 6 by all means. It's okay if you cannot remember the 7th one, it's okay. No, not a big problem. But first 6 definitely need to remember. Alright? Well then. Okay. Now, with that, I am going to end this class. Alright? With that, we are going to end this class. See you all tomorrow. Goodbye, everyone.